Let's now talk about the wireless networks devices. What are the devices that can communicate wirelessly? Let's start by the wireless access point. The wireless access point is a networking hardware device as shown in the picture. It connects the mobile devices to the wired infrastructure. From one side, it is connected to the registration jack 45, and to the other side it is connected to an antenna. So this antenna is used for wireless communication, and the RJ45 is used as an Ethernet interface for the wired infrastructure. So it has the interfacing between the wired infrastructure and the wireless network through the antenna and the RJ45 existing in the same device. The access point is a layer 2 device. It works in the physical and data link layers. The coverage area depends on the antenna, on the number of antenna existing in this wireless access point, and the strength of each of its antenna. Of course, wireless access point with one antenna covers less area than wireless access point with two, and 2 is less than 4, and 4 is less than 6. And of course, each antenna has its strength and its coverage area. So the antenna, its number and its strength determines to a great extent the coverage area of this wireless access point. We have several access points manufactured by several known vendors for networking devices. Cisco and other companies has produced a very well-known names for access points, such as Huawei and other networking companies. It may contain a DSL and a router in the same box. This is a wireless point for home connections, the one that contains DSL and a router. It is a variety of devices that are contained inside one box. So this DSL is connected to the telephone line, and the router is connected to the splitter, and then each of these devices interact to get the wireless device inside your home connected to the internet. The wireless access point can support several standards of the Wi-Fi, A, B, G, and N standards. It can be divided into several radio channels to avoid interference between the channels it is communicating with each other. This access point can act on channel 5, and the adjacent access point can act on channel 7. So we leave channel 6 in between unused so as to avoid interference between the communication channels. One access point can hold several SSIDs, either broadcasted or hidden. The speed and coverage of the access point depends on the brand and model of the manufacturer. A good one can cover bigger area and can have a higher speed. The access point signals can be obstructed by walls and can be stopped by long distances. This wireless signals can be reflected by walls and cannot bypass walls, and it is susceptible to being weakened through long distances. It can be configured through its firmware directly through Telnet, for example, or any other communication that can directly sets the configuration and saves the configuration over the firmware, or the configuration can be web-based. The access point can show a web interface that can be used by the user to configure it, to determine the channel, to determine the encryption protocol that will be used by this access point, and other settings for this access point. The access point can receive its power over the Ethernet connection. It can use the power over Ethernet concept to be powered if it is in the ceiling or in some place that is hard to connect power to it. The security features inside a wireless access point are many. The SSID itself can be hidden, so it is not exposed to the attacker. Access points used filtering based on several parameters. It can filter the traffic based on MAC addresses or based on IP addresses or based on port numbers, which means that it can filter the HTTP service based on port number 80. It can filter some domain names to access the network from inside to outside or vice versa. Access points use encryption techniques to communicate between the device and the access point. The mobile device and the access point can transmit and receive signals using the WEP, wireless encryption protocol, the WPA, or the AES protocols. Those three are encryption protocols that are used to encrypt the traffic between the wireless access point and between the communicating mobile device wirelessly. The AES is the most recent encryption protocol among these three. Let's have a look at the configuration of a wireless access point. This is the configuration page. This is the page that appears when configuring the access point through web interface. As you can see, you can enable VLAN, you can determine the SSID, you can determine the operation mode, you can determine the channel of communication, and you can, from the menu on the left, determine the security features that you want to apply over this wireless access point. Namely, you can determine the MAC filtering, which MAC addresses to filter and which MAC addresses to pass, which IP addresses to filter and which IP addresses to pass, and which domain names to filter and which domain names to pass. You can monitor the throughput, you can have statistics about the wireless communications, and you can have several features to configure through this access point using the web interface page. Let's have another device that can connect your network wirelessly, which is the USB modem. It connects PCs, laptops to the GSM network via mobile operator. So it is inserted inside the PC or the laptop to connect this PC or laptop to the mobile operator company through the GSM network. It depends on the network generation, so the speed can either be 3G or can be faster using the 4G or LTE network. It needs no wired infrastructure. It can be inserted inside the laptop with no wired infrastructure to connect this laptop to the internet directly through the wireless infrastructure. Of course, this USB modem has charging fees according to your subscription to your mobile subscriber and your mobile network. You should pay for this traffic passing through the GSM network you are subscribed to, so it is costly than the Wi-Fi network. It has less network speed than the Wi-Fi, and it uses more power of the mobile device such as the laptop or smartphone, more power than the Wi-Fi. It allows more flexibility and mobility since it can be connected anywhere covered by the mobile network and the mobile operator, so it allows more flexibility and mobility, and it can be connected through streets and through remote areas just covered by the mobile network operator. Smartphones are the terminals that are most commonly connecting to the wireless network. Smartphones and laptops are the end terminals in a wireless network. It's spreading fast over the world. We have so many statistics that says that smartphones are penetrating the markets of several countries, and it is increasingly spreading over the world in number and in the type and number of users. It can be connected to the internet through Wi-Fi. It can be connected through the GSM network. It can be connected to other mobile devices through the Bluetooth. It can also act as hotspot that can connect other devices through it to the internet. It can act as the access point for other devices to the internet, and this access point can connect them through the GSM network. Wi-Fi is less battery consuming than GSM in smartphones. If you connect through your smartphone to Wi-Fi and connect to the internet, you will consume less battery than connecting to the internet using the GSM network. charges for GSM depends on your subscription. You either pay a monthly subscription and uses the internet according to this subscription, or you can either pay as you go, pay as you download, pay as you use for the GSM operator you are subscribed to, and use whatever services you can use offered by this mobile operator. Thank you.
Subscribe now and press the bell icon. Never miss an update.